people often ask how our multi-beam technology works and why it's so much better than single-beam sensors. The short answer is that it's all in the maths. Imagine an LED firing a single beam of light through a liquid to a detector. Solids in the liquid reduce the light's intensity, and if you measure this change, you can measure turbidity, at least in theory. In reality, it's a little more complicated. As light covers distance, it naturally gets less intense, which could be misread as turbidity. That's why all sensors fix the distance between the LED and the detector. Then it gets trickier again, because dirt can build up on sensors, which blocks light and causes false readings unless it's cleaned off. Electronics also get worse as they age, so they might not send or receive as much light as they used to. This single beam measurement has too many variables to be reliable. The solution is a multi-beam sensor that self-compensates by doubling the lights in detectors and uses some ratiometric maths. The first light fires a beam to both detectors, one closer and one further away. Both detectors take a reading, and the readings are turned into a ratio. Now imagine dirt has been building up on the light. Both detectors read the change equally, but the ratio between them isn't affected by the change, keeping the reading constant and true. This time, imagine one detector is aging and giving low readings. This is when the second light lets us flip things around. Both detectors take a reading from the second light. The result from the first ratio is then placed over the second. This generates a new ratio, which compensates for variation in the detectors. By creating ratios instead of just taking readings and converting these ratios into a ratiometric formula, we remove all the factors that affect the reading except one, the turbidity itself. By calibrating the sensor, we can use turbidity to tell us the exact concentration of the suspended solids causing it, giving you more insight and more control than ever.